Hello class, this video covers section 8.4 compound interest. Last video we have learned simple interest. Then what is a compound interest? What's the difference between simple interest and a compound interest? Look at my table note. It's clearly compare and contrast the two types of important interests. Compound interest is a way to calculate interest. Every time we have the interest produced from the principal, and the interest will be included into part of the principal. The principal is growing. When the principal is growing, then the bigger principal will produce bigger interest. For example, let's say the very beginning we have one chicken. Chicken is the principal. By the end of the first year, the chicken laid 4 eggs, right? In the case of simple interest, the 4 eggs will stay as 4 eggs. And next year, the principal is still the one chicken. Every year, we have 4 eggs as the interest. So after 10 years, we should have 40 eggs, right? However, in the case of compound interest, by the end of the first year, we have the 4 eggs. And the 4 eggs will quickly become chickens. 4 eggs will quickly become 4 chickens and join the original chicken, make a group, and this group is the new principal. So the beginning of the second year, your principal is not the original chicken anymore. Your principal is the 5 chicken. Yeah, original principal with the interest from the first year. So the beginning of the second year, you have 5 chickens as the principal. And during the second year, because every chicken has the ability to produce 4 eggs, those 5 chickens will give you how many eggs? 20 eggs, right? 20 eggs. So by the end of the second year, you will have 20 eggs. And those 20 eggs will not stay as eggs. Those eggs will be quickly turned into chickens again. So the beginning of the third year, year 3, your principal is not those 5 chickens anymore. Instead, you're gonna have 25 chickens. Those chickens is your new principal. Because with the 5 chickens from the year 2 and the 20 eggs, the interest from year 2, at the beginning of the third year, all those money, all those invest, all those assets is your principal. And the interest rate will be applied during the year 3 to produce more eggs for you. I hope this is clear enough. The difference between simple interest and compound interest is, in the case of simple interest, interest stay as interest, principal stay as principal. So chicken still chicken, and eggs are still eggs. But in the case of compound interest, your chicken, you have more chicken. Your principal is growing because the eggs will turn into chickens. Your interest will be part of the principal for the next year. So you will have more chicken laid more eggs will give you more chicken, and you can see the exponential effect. When people say exponential effect, that refers to compound interest. Very powerful, very powerful. Let's look at the formal definition for compound interest. Compound interest is interest computed on the original principal as well as on any accumulated interest. Many savings accounts pay compound interest. So when you take a loan, those loans charge you simple interest. But for many savings accounts, for example, individual retirement account, IRA or HSA, health savings account, we mentioned that in previous section we talked about personal income tax, yeah, those savings account pays compound interest, right? So let me derive the formula for compound interest very quickly. We don't have to spend too much time. You might remember this formula from previous video when we talk about simple interest. Remember that? Yeah, simple interest I equals P times R times T. A is the future value of the loan. Future value of the loan equals the original principal plus I, right? So it's P plus P times R times T. And if we take out P and factor out P, then the parentheses will contain 1 plus RT. Yeah, RT is 1 because we only consider 1 year, all right? Yeah, so that's the simple interest formula for T equals 1, the first year. By the end of the first year, our future value of the account is A sub 1. Yeah, we are talking about, we start with the simple interest formula for the future value of the account, but we are going to derive the formula for compound interest. So by the end of the first year, the account has A sub 1, that much money, right? But during the second year, the interest R, annual interest R, is not going to apply on the original principal anymore because your principal will be bigger. Your principal for the second year is going to be A sub 1. All right, so we use the same formula. A sub 1 is the principal beginning of the second year. Then the future value is the accumulated balance by the end of the second year would be equal to A sub 1 times 1 plus R, right? We use the same formula. Yeah, the A1 here was P, is like a P in the formula above it. And A sub 2 here is A sub 1. So by the end of the year 2, you have A sub 2. During the third year, your interest rate will be applied on A sub 2, not P or A sub 1, is A sub 2 because your principal is growing, right? All the money in your account is going to be the new principal. So by the end of third year, your account is going to have A sub 2 times 1 plus R, right? So let me continue from here. A sub 1 is P times 1 plus R. So we're gonna plugging in A sub 1 equals P times 1 plus R. And then times 1 plus R. And that gives us P times, 1 second. My board has damaged in this part. So 1 plus R to the power of 2, right? Yeah. And A sub 2 times 1 plus R. A sub 2, we just got A sub 2 is P times 1 plus R to the power of 2. And bring down the factor 1 plus R. We have a P times 1 plus R to the power of 3. Okay, let's look at the formula here. We are talking about a compound interest. The interest is compounded annually. Let's say the end of every year. So the very beginning, your principal is P. By the end of year 1, this is how much money do you have. By the end of year 2, this is how much money you have. Yeah, I want you to see the similarity of the formula. So P times 1 plus R in the parentheses. That's your accumulated balance in the account, pays you compound interest, compounded annually. And this is how much money you have by the end of year 2. And this is how much money you have by the end of year 3. Do you see the pattern? What's the difference? We can see the exponent here is 1, right? Yeah, by the end of year 1, so exponent is 1. By the end of year 2, exponent is 2. By the end of year 3, exponent is 3. So you can try, keep going. Then by the end of year 10, is going to be your accumulated balance in the account pays you compound interest is going to be P times 1 plus R to the power of 10. Right? So 1 plus R here is called a compounding factor. I want you to please remember this definition, this concept. 1 plus R. R is the annual interest rate because this account we are considering pays compound interest compounded annually. 1 plus R is the compounding factor. How does the formula for compound interest look like? How does it look like? It's very pretty well formed. T is the original principal. A is your accumulated balance. So every time your interest is compounded one time, then you just need to multiply this compounding factor one time. So during the first year, your interest is compounded one time, right? Then just multiply the original principal by the compounding factor. If your money stays in the account for 2 years, your interest is compounded twice. Then by the end of year 2, your accumulated balance simply is just multiply the original principal by the compounding factor twice because your interest is compounded twice. If you leave your money in the account for 10 years, then your interest is compounded for 10 times, right? Then your accumulated balance in the account by the end of year 10 would be original principal multiplied by the compounding factor for how many times? 10 times. So very important. I hope you remember what is a compounding factor. 1 plus R. R is the interest rate, is the compounding factor. How do we calculate your accumulated balance in a savings account that pays you compound interest? Simply multiply the original principal by the compounding factor every time your interest is compounded. Okay, every time your interest is compounded. I have this table, my table note. One of the table note is about the compounding. You can see compounding as a process. As you can see, for compound interest, we have different types. The interest could be compounded annually, means once a year, or the savings account could compound your interest semi-annually, twice a year. Okay, yeah, by the end of June and then by the end of December, twice a year. Or your interest could be compounded quarterly, 4 times a year, or monthly, 12 times a year, or even daily. Either we use 360 following the banker's rule, or we use 365. Or you know some interest is compounded n times. We don't even know what is n. Yeah, n times. N is a variable. N is the variable. Yeah. If the interest is compounded n times, this is the formula. Let me explain. Okay, this is the formula. We should understand this formula without difficulty. By the end of year T, after T years, if you leave your money in the account for T years, and your interest is compounded annually, then the total times of your interest is compounded is T times. So that's how do we have the original principal multiplied by the compounding factor T times. So raise the compounding factor to the power of T. You should have no trouble to understand this formula. In the case of the interest is compounded semi-annually, twice a year, your compounding factor is different. Okay, it's still 1 plus interest rate. However, since your interest is compounded semi-annually, the interest rate here is not an annual interest rate anymore. It's the semi-annual interest rate. It is the annual interest rate divided by 2. You can understand that as your chicken's productivity. If you make your chicken lay eggs more often, then the chicken's productivity will be lowered, right? So in the case of semi-annually, interest is compounded semi-annually, your compounding factor is 1 plus semi-annual interest rate. Same thing, if you leave your money in an account for T years, since the interest is compounded twice a year, then the whole entire time, your interest will be compounded for 2 times T times, 2T times. And simply just multiply the original principal by the compounding factor for how many times? 2T times. Do you see the pattern? Do you see the pattern? So what if your interest in the account is compounded quarterly, 4 times a year? Yeah, by the end of the March, by the end of June, by the end of September, by the end of December, suppose you deposit your money at the beginning of the year for convenience, then your compounding period would be 3 months. Yeah, every 3 months, your interest is compounded 1 time. And in this case, your compounding factor is still 1 plus interest rate, but it is 1 plus quarterly interest rate. It is 1 plus annual interest rate over 4. Okay? And let's say you keep your money in the account for 10 years, and 4 times a year for 10 years. So your interest in total will be compounded for 40 years, right? 40. Then what's your money by the end of the year 10? Simply multiply the original principal by the compounding factor for how many times? 40 years, 40 times. If it's for T years, then 4 times T times. So the exponent is 4T. Do you see the pattern? If the interest in the account is compounded monthly, every month, once a month, then the corresponding compounding factor is 1 plus monthly interest rate. If the interest is compounded daily, then the compounding factor is 1 plus daily interest rate. And by the end of the year T, yeah, let's use T as the number of years, then your money would be, your accumulated balance would be the original principal multiplied by the corresponding compounding factor. How many times? The total times of your interest is compounded. And that is also the number of compounding period. Yeah, the compounding period for 1 year is 1 month. Then for 10 years, then that's gonna be so if your compounding period is 1 month, in the case of your interest is compounded monthly, then for 1 year, the number of compounding period would be 12, right? For 10 years would be 12 times 10. For T years would be 12 times T. So the exponent is always the total number of compounding period in the longevity of your account. Yeah, when you the entire time when you keep your money in the account, is also the number of times your interest is compounded in the account. Does that make any sense? So the second formula is actually a general formula for all the previous 1, 2, 3, 4, 5 formulas. When the interest is compounded annually, n equals 1, then we got this formula. When the interest is compounded semi-annually, n equals 2, we got this formula. When the interest is compounded quarterly, then n equals 4, we got this formula. When the is monthly, then n equals 12. When it's daily, n equals 365 or 360, depends on the problem. And there is a case that the interest is compounded continuously. Imagine your chicken is laying eggs continuously laying eggs, and the eggs quickly become new chicken, and your chicken is, the group of your chicken is growing continuously, and they, so in that case, we have a different formula. When n approaches infinity, then the limit of this expression is this function, p times e to the power of r times t. P is the original principal, r is the annual interest rate. Knowing r in the problem always annual interest rate, and you can adjust it depends on how is the interest going to be compounded. But the R here in the formula always refers to annual interest. T is how many years your money is kept in the savings account. And what is E? E is the natural number or Euler number. You might remember Euler diagram from previous chapter, right? Same guy. Yeah, it's an irrational number. Same important with pi. If you look at your calculator, probably very close to pi, you will see E. E is around equal to 2.718. Yeah, less than 3, bigger than 2. It is an irrational number. Alright, so those are the formulas you need to grasp when you process problems, compound interest problems. Okay, now let's see how do we use them. We're going to use the formulas to solve problems. Let me double check the video. It's recording. Okay, I am not muted. Okay, awesome. So let's look at this example. You deposit $2,000 in a savings account at a hometown bank, which has a rate of 1.6%. It doesn't say this annual interest rate, right? But it is annual interest rate as default. We have two parts in this problem. Part A, find the amount A of money in an account. So A is the future value of your account, or accumulate the balance in your account after 3 years, subject to interest compounded once a year. Okay, so your N is 1, annual interest, right? It's supposed to be a lowercase n. And your original principal, we are organizing the information we are given. And your T is 3, right? So those are the information. And what formula should we apply to calculate A? We should use the first formula, right? Yeah. And A equals, I'm going to write the formula right here. A equals P times 1 plus R to the power of T. And that's the formula we need to use. It's the first formula in the table. This one, on the upper right corner. And now all we need to do is just plugging in. Okay? We just need to plugging in. We're going to plug in P is 2000. And then we are going to, I'm going to use this formula. A parentheses. In the parentheses, we have 1 plus, oh, we're missing an important information. R equals, annual interest rate equals 1.6%. 1.6%. Yeah, right away, I will convert that percent to its equivalent decimal, 0.016. So here, in the parentheses, when we apply the formula, we have a 1 plus 0.016, 0.016. And then raise that compounding factor to the power of 3, because we have 3 years, right? You see that? And you use your calculator. You either use your simple calculator, or you can use the TI-84 graphing programming calculator that I strongly recommend in the syllabus. So let me show you how. Okay, let me show you. I'm going to enter this expression into the calculator. In order to do that, I need to share my camera. This one. The focus of this section, I think a formula, you probably have no trouble to find the correct formula to apply, is how do we calculate, because you do need to use a calculator. You cannot get an answer without using a calculator. This is a camera. Are you able to see it though? This is a camera. Why is it so small? Should I turn on this? Share video. Let me do it again. Okay, let's try. So the original principal is $2,000. So we enter 2,000. And then I enter the left-handed parentheses and 1 plus the annual interest rate, 0.0. I need to look at what is the annual interest rate. 0.016, 0 point, oh, my bad. Let me do it again. 2,000 multiplied by parentheses 1 plus 0.016. Close the parentheses and then raise the compounding factor to the power 3. As you can see, the expression you see here in the calculator is exactly the same with what I typed in the note. And now you enter. We have $2,097. And if we round it to, let's see how do we round the problem. It doesn't say, but when you do your homework in MATLAB Math, you must read the information or instruction of the problem. How do you round it? How about let's round it to the nearest cent? That should make a perfect sense, right? So we are going to round it to the nearest cent. So we keep 2 decimal places. Since this 4 is less than 5, we are going to round it down. So the answer is going to be 2097.54. So it's going to be, you can round it. This is the focus of this section. As I mentioned earlier, I don't think it's difficult for you to choose the correct formula, but how do you plug in the values to get a correct answer? That might be challenging. So please get a good calculator. I have 2097. The calculator might be pricey, so you can try to borrow one. 54. In the beginning, 3 years ago, you only deposited $2,000. By the end of year 3, you have almost $100 as interest, right? Yeah, that's how much the value of your account grows. And that is the accumulated balance by the end of year 3. Part B is to find interest. Interest, let's still use I to represent the interest. Just know, interest here is a compound interest. It is the difference between the future value of the account and the beginning value of the account. P is the original principal. A is the accumulated balance after 3 years. Is more. So we use A to minus P, we got the interest. So that is 2097. Oh, hold on. I think I need to, I need to share this again. Then you can see. I need to share this again. Not very convenient, but that's what I can do so far. It's my own device, and this is the best that I can do. So we were here. The answer we rounded to the nearest cent is $2,097.54. And the interest is the difference between the accumulated balance and the original principal, $2,000. So your interest over the 3 years is 97.54. Right? Let me double check. We are sharing this. Yep, should be fine. All right, so let's look at the next example. You deposit $7,500 in a savings account that has a rate of 1.2%. The interest is compounded monthly. Compounded monthly means your N in the formula is 12. Again, it's supposed to be a lowercase n. Your key original principal is $7,500. Your interest rate, annual interest rate R is 1.2%. As decimal, it is 0.012. That's all the information we have, right? How long? For how long? How much money will you have after 5 years? So T equals 5. So we are going to use this formula, right? Since the interest is compounded monthly, the formula for the accumulated balance would be A equals P times compounding factor would be 1 plus monthly interest rate, and then raised to the power of the total number of times of your interest is compounded. That is n times t. And your n is what? Is 12. Your n is 12. 12 here, 12 here. All right, and then you enter the value of the given variables. P, the value of the variables. P is given 7,500 and 1 plus, and R is 0.012 over 12, and raise that to the power of 12 times 5. 12 times 5 we know is just 60, right? Yeah. So you can manually calculate, is your option. How do you calculate and get a result? I'm just trying to recommend the best way I think, or the easiest way for you. The easiest way for you is to use the calculator. So now we are going to go back the TID for calculator. Share camera. This one. Share camera. Share primary content. You are sharing this. Share camera. Okay, I hope this is recorded. Okay, our principal, 7,500, right? And left-handed parentheses, 1 plus. I don't even have to really calculate what is the monthly interest rate. All I need to do is to get another set of parentheses and then divide the annual interest rate, 0.012, by 12, and then close the parentheses. So the inner set of parentheses is framing the monthly interest rate. And then now I'm going to close the compounding factor and then raise that to the power of 60, 12 times 5, right? And then we have the answer. Yeah, pause and repeat this part. Very, very important. By the way, you don't have to really do exactly the same thing that I do. It's just really is a best way that I think will make your job easier. And you should try, at least you should try. So now I'm going to go back our note. Once we see the tunnel, yeah, I'm sharing the whole entire screen. Yeah, so the value we got is around equal to 7963. $7,963. We round it down, 53 cents. You don't have to always round it down, round it to the nearest cent. Depends on the question. Very, very important for this section. Part B, find the interest after 5 years. So interest is your accumulated balance, A minus your original principal. So that is, use this value to minus 7,500, right? Yeah, so that is $463.53. Similar with the previous question, only difference is the first example, interest is compounded annually. And in this example, interest is compounded monthly. So your N is 12. Your compounding factor is 1 plus the monthly interest rate. And your exponent on the shoulder of the compounding factor is 60, not 5, it's 60, because 12 times a year for 5 years, that is 60 times. What if we have a compound interest problem, but the problem is not finding accumulated balance A, the future value of the account. Instead, we told you the future value that the owner of the account wants to achieve, and how do you determine the original principal? So this is the formula. Okay, in this formula, we call 1 plus R over N discounting factor. Discounting factor. Yes, it looks exactly the same with compounding factor, but it is called a discounting factor when the process is go from future value to present value, go backwards. Yeah. So when we go from P to A, we are multiplying this factor, is called a compounding factor. But when we go from A to P, then we are dividing that factor. Then we call the factor discounting factor. Does that make any sense? Okay, so let's see this example. How much money should be deposited today in an account that earns 6%? That's very high. Compounded monthly, so that it will accumulate to 20 grand in 5 years. Let's organize the information we have. We have annual interest rate 6%, that is 0.06. We have N equals 12. Yeah, it's annual, is a monthly, compounded monthly. It will accumulate to, okay, so future value that you want to achieve is 20 grand. 1, 2, 3. 5 years, T equals 5. So you want to find out how much money you should deposit today in order to get those money in the future, in 5 years. So the formula is using the future value to divide by compounding factor. Since your interest is compounding monthly, your compounding factor is 1 plus R over 12. Over the 12 years, over the 5 years, your interest is going to be compounded for 60 times, right? 12 times 5. 12 times 5 is 60. Simply just divide by the compounding factor. And let's plug in the values. A is 20 grand, 234, and this is 1 plus. R is 0.06, 0.06 over 12, and then to the power of 60. Okay, now let's go back the calculator again. Share camera, HD camera. Oh, hold on. Did I enter something wrong? Let me do that again. You are sharing. Okay, so I am sharing. You are sharing HD camera. All right, so this is what we do. Turn on the calculator. We are going to do 20 grand. 20 grand is your future achievement, the future value you want to achieve in the account. So 20 grand divided by, and I'm going to use how many sets? Two sets of parentheses. This outside parentheses is going to frame the compounding factor. But your compounding factor is 1 plus monthly interest rate. So I'm going to use a specific one set of parentheses to frame the monthly interest rate. What is the monthly interest? 0.06. Okay. 0.06 divided by 12. And close the monthly interest rate. And then close the compounding, sorry, in this case, discounting factor. Yeah, discounting factor. And then raise the discounting factor to the power of 60. All right, let me double check. So we have 14,827. 6% is very high and it's monthly. Let me double check. If we go to apps, finance, TBM solver, so 60 times 6%. Is that 6%? Yeah, 6%. And present value is something we're going to calculate for. Future value is 20 grand. 1, 2, 3, 4. This is 12 because monthly. And if we go back to solve, I'm using an app in a calculator. Yeah, same thing. Same thing. That means our answer earlier is correct. Is 14827. So now I'm going to share the entire screen again. Let's go back our notes. What happened? It's right here. Let me do it and share this. This one. I'm not sharing. Let me turn off that. Let me share this. This entire screen. Okay, now we are sharing. So the answer is around equal to 14827. 0.45. You might wonder, we rounded up. Yeah, so very, very important. When you are looking for present value, what the original amount of money you need to deposit to secure a certain amount of money in the future, you want to always round it up. Okay, if we round it up to the nearest cent, it's supposed to be 45. Even the digit after 4 is 3. Like following the normal rounding rule, you should round it down, but no, always round it up. Otherwise, you might a little bit short to reach that goal. Like it says here, remember to round the principal up when computing present value, so there will be enough money to meet future goals. Okay? If A, the future value is estimated to be this many, we would round this value up, just like what I just did, in order to accumulate 20 grand in 5 years. Okay, this is very, very important. Do not lose the point in MATLAB math just because you did not round it correctly. The question will give you the correct instruction. And let me double check the recording. You're sharing and you are recording. Okay. So let's continue this example. Parents wish to have 80 grand available for a child's education. If the child is now 5 years old, how much money must be set aside at 6% compounded semi-annually to meet their financial goal when the child is 18 years old? All right, so let's sort our information. We have future value 80 grand, 1, 2, 3, 4, and we have annual interest rate 6%, 0.06, semi-annually, so n equals to 2. T is not 5, is not 18, is 13, because he's already 5 now. In 13 years, he's gonna be 18, so the time is gonna be 13. And we are going to look for P, right? So the formula is this, 1 plus R over 2, semi-annually, n equals 2, twice a year, so not 12, 2, to the power of 26, twice a year for 13 years, so the total number of interest is compounded is 26 times. And let's plug in the values we have, 80 grand, 2, 3, 4, all over 1 plus 0.06 over 2 to the power of 26. Yeah, by the way, you already know 0.06 divided by 2 is 0.03, right? Of course, you can just use 0.03 in a calculator. Now let's go back to find the value. Share camera, HD camera. Share camera. You are sharing the camera. Okay. So we have 80 grand, 64. Let me double check the data. And then divided by. If you want to separately calculate the semi-annual interest, totally fine. Then you do not need to use many sets of parentheses. That might make your job easier as well. So 1 plus 0.03 semi-annual interest rate, right? Close the parentheses, raised to the power of 26. So that's the value. So you must deposit for your child 37 grand, 95 cents, 58. We're going to round it up today in order to have 80 grand when your child is 18 years old for the education purpose. Go to college, pay the tuition, right? Okay, let me share back. Okay. So our value, we round it up, is going to be 37 grand, 95 dollars. We round it up, 58 cents. 58 cents. Next question. So okay, so that's that. Next topic, the last topic is about effective rate. Another name is effective annual yield. You might not have heard this before, but you might have heard APR and APY. So I have a table note explain the relationship between APY, APR, and our effective rate. Is one of my table notes right here. Okay, they are the same thing. In the case of borrowing, our effective rate refers to the APR. Yeah, when we say APR, you buy a car, get a car loan, APR, that actually is the effective rate or the effective annual yield. When you invest, we do not talk about APR. We say APY because you invest, you want to have gains, that is yield. So it is APY. APY is the same with the effective annual yield. So it's the same thing, but it has different names in different situations. Our effective annual yield is the APR in the case of borrowing. Our effective annual yield is the APY in the case of investing. Yeah, why this concept is so important? Because it gives us a way to compare two investing options or to compare two or more borrowing options. Yeah, what we can do is when we borrow, we want as low APR as possible. When we invest, we want a corresponding APY as high as possible. Pretty intuitive, right? Okay, so let me take a little time to prove this formula for the effective rate. How about let's look at the formal definition first. Suppose that, okay, effective annual yield. The effective annual yield or the effective rate is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. So we are going to use the definition of effective rate to derive the formula. So the first formula is the future value of the loan for the simple interest, right? The second formula, we actually have a T here. Second formula is the compound interest formula we just learned, accumulated balance. So we only consider 1 year, so T equals 1. We don't have it anymore, okay? And we are going to change the R in a simple interest Y. And we are going to equate the two A. Yeah, in the future, after 1 year, they produce the same amount of money. So we are going to equate this part. So the 2A is supposed to be the same, right? So we are going to equate this part with this part. And we would have 1 plus y equals 1 plus r over n to the power of n. And minus 1 from each side of the equation, we would have y equals 1 plus r over n to the power of n minus 1. That's how do we derive the formula for the effective annual yield or the effective rate right here. Okay? Yeah, the test is going to be close book, close note. So you might want to make an effort to memorize those formulas. Let's apply. This is how do I remember the formula. It only takes me even just less than a minute to derive the formula. And that's how do I remember. I know the definition. I know the process of deriving the formula. Example, a passbook savings account has a nominal rate of 5%. That is the R. The interest is compounded daily. Find the account's effective annual yield. Assume 360 days in a year. Okay, so let's organize the information we have. N equals 360, following the banker's rule, because it's compounded annually. We have the nominal rate. It's not actually the, so later, once we have our result, we're going to compare the effective rate and with the nominal rate to see the difference. R equals 5%, as decimal is 0.05. We are going to find the effective rate or the effective annual yield. Formula 1 plus R over N to the power of N minus 1. Plug in the values. 1 plus R is 0.05. Divide that by 360. And then to the power of 360. And then minus 1. Let's see what do we have. We're going to use the calculator one more time. Share camera. Share camera. You are sharing HD camera. Okay, so we are calculating the effective rate. We have a parentheses. In the parentheses, we have 1 plus the daily interest rate, right? Let me double check what is the 0.05, 5%. So 0.05 divided by 360. So in the small parentheses, we have the daily, nominal daily interest rate. Close the factor. That is still compounding factor. And then raised to the power of 360 because we only consider 1 year. And then minus 1 from that. And we will have a decimal. And we are going to convert the decimal to its equivalent percent. Right? We run it up. How about 5.13%? 5.13%. Let me share back. The effective rate is around equal to 5.12%. Is very close to the nominal rate, but higher than the nominal rate. Because this is a savings account. This is the case of investing. This is APR. This actually is your APR. It's actually bigger than the nominal rate. All right, so that's how do we find effective annual yield. More examples. The last example, I'm going to use a different method to calculate. We are going to use the TI-84 calculator, and we are going to use the finance apps, the apps, finance app in the calculator. In the finance app of the calculator, we have a T time value of money solver. Okay, so we are going to use that function in the calculator to process the compound interest problem. Let's get started. I hope you have this information somewhere convenient. Then you can watch the video. Okay, so and you know what is the information. So we have 4 parts, A, B, C, D. The first part, interest is compounded semi-annually. Principal is 4,000. Annual interest rate is 1.9% for 5 years. We need to find the balance and the interest. Yeah, we are not going to use the formula anymore. We are going to use the app. Many students will find this chapter pretty challenging. To make it less challenging, get yourself a good calculator and watch the video and learn the easiest way to get the answer. I'm going to share the camera. Okay, you are sharing HD camera. All right, so do you see the APPS, this key? Look at your calculator. You should have this key right here, apps. So enter apps, and you will see finance. I only have one app. I had other calculator has more than one app, but this one is only have one. But that's the only one that we need. So finance, convert that, confirm that. And the first function in the list is TVM solver. TVM stands for time value of money. Money has values. The money today, $1 today, worth more than the $1 in a year because of the inflation and also because of the interest. So we confirm that function. The first item is big N, right? Yeah, big N is how many times, the total number of times your interest is compounded. Now you need to look at your note, the first row in the table. The interest is compounded semi-annually for 5 years. Semi-annually for 5 years. So that's 10 times over the 5 years, right? Twice a year for 5 years is 10. And the next item is I%. You know, it's very convenient. You do not have to ever convert your percent to decimal. Since the interest rate is 1.9%, all you needed to enter is 1.9. Yeah, do not worry about the percent because it's defaulted as that. PV here represents the present value. Present value is your original principal. In our problem, part A, your original principal is 4,000. So enter 4,000. 3. And a PMT payment, do not worry about that. Just keep that as 0. Because you don't deposit or you do not withdraw during the 5 years, so just 0. FV stands for future value. So how much money do you have in 5 years? That's the amount we are trying to find, right? So you can put a 0 here or any other number because we are going to go back in a moment. And very, very important, P per year and C per year, you need to be careful. Since part A, the interest is compounded semi-annually, you need to put 2 here. Okay, you need to put 2 here. Because the interest is compounded semi-annually. If you leave 12 there, that means the interest is compounded monthly, 12 times a year. And now you go back, future value, you see the is blinking, right? Future value. And you are going to solve for future value. How do you solve? Look at this green key. Alpha, enter. Solve for the future value. And that value, do not worry about the negative sign. That value is your answer. Is your accumulated balance in 5 years. 4396.67. 66, we rounded to the nearest cents. So I'm going to write the answer here. It is 4396. .67. 66. For the interest, simply use the balance to minus the principal. Okay? Look at your note. The last question. The part B has principal 2,500. Annual interest rate 0.9%. Compounded quarterly for 6 years. And we are going to use the app to do that. Do part B. So we go back the first item. Okay? First item. And read your note again. Quarterly for 6 years. Quarterly means 4 times a year. For 6 years, 4 times 6 is 24. So you're going to enter 24 here. And then annual interest rate is 0.9%. So you only need to enter 0.9. You don't need to convert. Present value, your original principal, 2,500. 2,500. Payment is 0. Future value is something we are trying to solve for. And we go down. Very important, because part B is quarterly. You're going to enter 4 here. Enter 4 here. And then you go back, future value, to solve for the future value. All right? 4 times a year for 6 years, 24. 0.9% annual interest rate. Originally, you have $2,500 in the account. Then after 6 years, you are going to have, as you can see, $2,638.55. Let me write the answer in a part B. We're going to have 2638.55. Future value, we don't have to always round up. We follow the normal rounding rule. And use the balance to minus original principal, you would have the interest. Part C, look at your note. Part C, your original principal is 2,500. Annual interest rate is 3.5%. Monthly for 4 years. Go back. Monthly for 4 years. The first item, monthly for 4 years. So 12 times 4. You don't even have to calculate it yourself. It will calculate it for you. 12 times a year for 4 years, 48 years. 48 times, sorry, 48 times. And the annual interest rate is higher this time for part C, 3.5. So just enter 3.5. Original principal is the same as earlier. And monthly, so here P per Y and C per Y is going to be 12. In the future sections of this chapter, we are going to continually using the TI-84 calculator to make your job easier. So please get a calculator as early as possible. And we are going to solve for the future value. And let me double check. Yep, everything looks fine. Let me copy the answer for part C. 2875 dollars 10 cents. We rounded up 10 cents. Last part, part D. Original principal 25,000. 5.5% daily for 360 times a year for 20 years. Let's see what's that. Let's go back. I hope you are watching this, because it will really make your job easier. So it's daily, so 360 for 20 years. You multiply 360 by 20 years. That's the total times of the number of times of your interest will be compounded over the 20 years. And the annual interest rate, 5.5%, so enter 5.5, 5.5, and your original principal, I think is 25 grand. 1, 2, 3, no, 2,500. 25 grand. And since your interest compounded daily, so you have to change the P per Y and the C per Y to 360. And then go back, future value, solve for the future value. Okay, that makes sense. Because the interest rate is very high, it is over long term 20 years and is compounded daily, very frequently. So the future value is a lot, kind of like tripled the value you originally deposited. Let me enter the value 75,097 dollars and 84 cents. I hope you really watched this part. Let me share back. We use a different method. We use the TBM solver in TI-84 calculator. Quickly get the results for the last example on the guided note. So you can find the interest yourself. All right. So we have a lot of information in this video. Hope you are watching it. Thank you guys. I'll see you in the next video.